Hello everyone, welcome back to our SPSS training with Asson Tech Hub. In this video, we are diving into statistical and hypothesis testing in SPSS. You will learn how to run t-tests, ANOVA, and chi-square test, and how to interpret the results using real data. So this is the data we are going to be using for the sake of this demonstration. We have a data set that contains the gender, the test preparation level, whether complete or not, the parental level of education, math score, and writing scores. So this is the variable that are entailed in this dataset, and this is what we're going to be using for our hypothesis testing. Now we will run t-test to see if there is a significant difference in math score between the male and the female student. So under gender here, so that means we're going to be running the t-test between the gender and the math score variable. To do this, click on Analyze, click on Compare Mean, click on Independent Sample t-test. It will display the Independent Sample t-test dialog box. In this case, we are testing the math score against the gender. So we're going to move the math score into the testing variable. So select the math score and click on the arrow to move it to the test variable. Now click on the math score and the gender and click on the arrow for the grouping variable to move it to the box for the grouping variable. Next, click on Define Groups. For group 1, we're going to define male to be the group 1 and we'll define female to be the group 2. Then click Continue and click OK. And that is all. The output is ready. Here, the first table gives us the group statistics, which shows us the total number of male and the total number of female. So this data set entirely contains 1000 observation. And out of the 1000 observation, 482 is male and 518 are female. So we are not concerned with the rest of the information there. Let's move down. So we say we are doing a t-test to see if there is a difference in math score between the male and the female student. So for the independent sample t-test, you will have the output like this. For the Leibniz test for equality of variance, we have the significant value to be 0.529, which is greater than 0.05, meaning equal variance can be assumed between the two groups, that is the male and the female gender. Remember, we say demonstrate your hypothesis. For this particular test, our null hypothesis is that there is no difference between the male and the female gender in terms of the score of the maths. While the alternative hypothesis is that there is difference. Remember, the null hypothesis is always neutral. It means there is no difference. But the alternative means there is always difference. So for this, our Leibniz is just telling us about the equality of the variance. So let's move to the t-test where we made our final conclusion. For the t-test, we have the t value to be 5.383 and we have the degree of freedom of 998. We're going to be making our judgment and conclusion based on the significant value. So remember, if your significant value is less than 0.05, you are to reject the null hypothesis, which means there is a statistical difference. But when it is greater than 0.005, you will fail to reject the null hypothesis, which means there is no difference. In this case, our significant value is less than 0.01. Since the p-value of since the p-value is 0.0 is less than 0.01, this indicates a statistical significant difference between the two gender of math score, which means that the score in maths between male and females differs. We have what explain it further here, which is the mean difference. The mean difference is 5.095, meaning one group's math score is 5.095 points greater than the other. In this case, if the result is positive, it means the group 1 is the one that is higher. And if the result is negative, it means the group 2 is the one that is higher. Remember, in our group 1, we define male. So male is the one that is having this higher point. Therefore, in conclusion, there is a statistical significant difference between the two groups, the male and the female, in relation to their mass score, because one of the group, which is the male group, score on average 5.095 points higher than the other group, which is the female gender. So this is for t-test. Now let's run our second test. Our second test is ANOVA. Now let's compare the writing score across different levels of parental education using ANOVA. What is our hypothesis here? Our hypothesis, the null hypothesis, is that there is no difference in writing score across the level of parental education, whereas the alternative is that there is difference. So now, in this case, to run this analysis, click on Analyze, come down to Compare Mean, click Compare Mean, click on One-Way ANOVA. It will display the One-Way ANOVA dialog box. So here we have the dependent list and the factor. Our dependent list here is the writing score. So we click on the writing score, I click on the arrow to move it to the dependent box. Now, the factor we are considering here is the parental level of education. So we select the parental level of education and click on the arrow to move it to the factor. So from here, we click on OK. And as you can see, our ANOVA table has displayed. We have all the elements of ANOVA table. As you can see, we have the sum of square, the degree of freedom, the mean square, the F, and the significance. I'm not going to be explaining all this. I will just focus on what is of interest to us. For the F statistics, we have the F statistics to be 14.442, which is large value, suggesting that the difference between the group are significant. And we have our p-value to be less than 0.001, which is below the threshold of 0.05, indicating that the difference between the group are statistically significant. In conclusion, we can say, since the p-value is less than the p-value of less than 0.001 is less than the significant level of 0.05, we reject the null hypothesis. This indicates that there is a significant difference in writing score based on the parent level of education. Now, let's consider our third test. Let's examine the relationship between gender and test preparation, whether the completeness or not completeness of test preparation is influenced by gender. Okay, to do this, click on Analyze. Then from there, click on Descriptive. Click on Cross tab. From the cross tab, we're going to move the gender variable into the row, and we'll move the test preparation variable into the column. Then click on Statistics and select chi-square. Click Continue. Then click on Cell and select Row, Columns, Total, and click Continue. Then click OK. And yes, now we have our output. The first table there is a cross-processing summary, which gives us like a basic statistics of the data that you see. The total observation is 1000, and here is the cross-tabulation table between the gender and the test preparation variable. Let's interpret our chi-square test table. So from our chi-square table here, you can see our level of significance. Let's interpret the Pearson chi-square. The Pearson chi-square gives us 0.849. What does it mean? This means that there is no significant association between student gender and whether they complete the test preparation or not, as a p-value of 0.849 is greater than 0.05. Then this means that the distribution of students who completed or didn't complete the course is similar across the male and the female group episode. In this video, we have covered 3 essential hypothesis testing using SPSS: t-test, ANOVA, and chi-square. Remember to always state your hypothesis and use the p-value to make informed conclusion. Thank you, and see you in the next episode.